Hello everyone, welcome to my YouTube channel Captain Chandan. Today I will cover a topic that is time. Basically it has a two part. First is solar system and second is time numerical. Example UTC LMT related problem. So first in this video we'll cover a solar system. Then in next part we'll cover UTC LMT related problem. Thank you for watching.
Measurement of time are based on the Earth rotation about its own axis. So in 24 hours, Earth complete one rotation on its own axis and it rotate from west to east. Remember that one. The second is the Earth rotation around the Sun and it take approx 365 days to complete one rotation around the Sun. And the third is the movement of solar system in our galaxy, and the last one is the movement our galaxy in universe. So there is a four reason to measurement of time. Kepler law. The full name of Kepler is Johannes Kepler, and he born 27 December 1571 in Germany. There is a very interesting fact about Sir Kepler. He used to see stars and planets all the night. He made many telescopes, and using this telescope he used to study planet. And his wife used to say that telescope is his first wife and she is the second. And we know him because of he gave us a law of planetary motion. So we'll study that one. So we'll discuss about the Kepler first law. The orbit of each planet is an ellipse with the sun is one of its foci. For example, if we are talking about a circle, so circle have a one center. But again, if we are talking about the elliptical or we can say ellipse, so there is a two foci point. If we are talking about one point, we call focus. In center we can say one point, that is focus. That is a singular word. But if we talk about both point, then we call foci, that is a plural word. So let's put sun in one of its foci and the earth rotate around the sun. So that is the first law. The orbit of each planet is an ellipse with the sun is one of its foci. Perihelion. When the earth is nearest to the sun in an orbit, it is perihelion. As you can see in the diagram, the earth is near to the sun and it is occur on 4th of January. That is called perihelion. Aphelion. The earth is a point farthest from the sun known as Aphelion. So Aphelion occurred at 4th of July and the earth is farthest from the sun. So both point is important for Dgca exam. 4th of January, that is perihelion, and 4th of July, that is aphelion. And distance from earth to sun at perihelion will be 91.4 million statute mile. And distance from sun to aphelion, that will be 94.6 million statute mile. Remember both terms. Kepler second law. The line joining the planet to the sun known as radius vector swept out equal area in equal time. So radius vector is the line joining to the sun from earth. Now we'll take two examples of earth. The first position is here and the second position is here. So in 30 days earth travels some distance and make some area here, make some area. Now we'll go for the second position of the Earth. In 30 days again, it covers some distance and makes some area here. So what Kepler law said that area A equal area B. Radius vector shift out equal area in equal time. If the time is 24 hour, then you must take a 24-hour here. So the area will be same. That is a Kepler second law. In an elliptical planetary orbit, the orbital speed is fastest at perihelion and slowest at aphelion. This is also important. So fastest at the perihelion and slowest at Aphelion. This also came under Kepler's second law. Let's discuss some important point. The Earth rotates about its geographical north and south axis in anti-clockwise direction when viewed from above the North Pole and clockwise from South Pole when viewed from the South Pole. This rotation determines our measurement of day. So here, if you see the Earth from the North Pole, it appear to rotate anti-clockwise. This is important for this exam also. And when viewed from South Pole, it appears that Earth is rotating clockwise. And this rotation determine, and or you can say this rotation give us a measurement of day. So in 24 hour, approx 24 hour, Earth rotate one cycle. The second important point, the Earth orbit the Sun in anti-clockwise direction. The orbital period determine our measurement of year. As you can see, if you view from anywhere, the Earth rotate its anti-clockwise direction to the Sun. The orbital period determine our measurement of year, approx 365 days. It complete one orbit. The season. The cause of season is the inclination of the Earth. The Earth axis is inclined at an angle of 66.5 degree to the orbital plane, and this is often stated as 23.5 degree to the normal to the orbital plane. As you can see here, 66.5 from the orbital plane to the spin axis, right? But 23.5 degree to the normal from spin axis. That's why season that's the reason of season changing. As you can see here in the diagram, 66.5 degree from the orbital axis and 23.5 from the normal. The Earth is tilted. You can see clearly here. This is the reason for season changing. Various position of Earth while orbiting. First, when Sun direct over 23.5 degrees south, that is called winter solstice and occur on 21st December. So the sun ray will be direct on 23.5 degrees south. So 23.5 degrees south will be hotter than 23.5 degree northern part, or you can say in the northern part. So 21st December in northern part there will be cold, and 23.5 degrees south there will be a hotter days. When sun over 23.5 degree north, that is called summer solstice, it occur June 21. When over equator, it called spring equinox, occur on March 21. When sun again cross the equator on September 21, called autumn equinox, and it's occur on 21st of September. So remember the date, and when sun remember the date, it will help you to solve question in Dgca exam. The sun appeared vertically above 23.5 degrees south on the 21st of December. This is known as, for northern hemisphere we call winter solstice, and for the southern hemisphere we call summer solstice, because 23.5 degrees south the sun ray will be direct over there. So on southern hemisphere it will be summer, and in northern hemisphere it will be winter. The sun will be appear above 23.5 degree north on 21st of June at northern hemisphere, that is called summer solstice, and southern hemisphere we call winter solstice. The sun crossed the equator from south to north on about 21st of March. This is known as, for the northern hemisphere we call a spring equinox, for southern hemisphere we call autumn equinox. 6 months later, it crossed the equator from north to south on about 21st of September. In northern hemisphere we call autumn equinox, and for the southern hemisphere we call a spring equinox. During the period of one day, the sun appeared to move along the parallel of latitude from east to west. This is very important terms. The plane of equator is called plane of equinoctial. The plane of Earth orbit around the sun is called plane of ecliptic. The plane of ecliptic and plane of equator are inclined each other at an angle of 23.5 degree. We already discussed that one. The angle is called obliquity of ecliptic. At a given time of year, the angle that the sun is above or below the equator determines the season and affect the length of day and night. The angle is known as declination. The sun declination change annually. Between 23 degree north, when sun over the Tropic of Cancer, through 0 degree is equator, to 23.5 degrees south when sun is over at Tropic of Capricorn, and then back through the 0 degree, that is equator, again to 23 degree. Point to remember: reason for season, that is inclination of Earth. Due to inclination of Earth, there is a season 23.5 degree from the normal plane and 66.5 degree from the orbital elliptical plane. Reason for day and night having different duration due to inclination of Earth. Rate of change of day and night is greatest at spring and autumn equinox. Maximum declination of sun is 23.5 degree from equator on 66.5 degree from pole. Now we will understand the concept of sidereal day and apparent solar day. In this diagram, Earth is pointing to the sun and star while rotating on own axis and moving on elliptical path around the sun. After 23 hours 56 minutes, the red pointer is pointing the star, not the sun. That is called sidereal day. And after some time, Earth rotates and pointing to the sun. That is called apparent solar day, and it varies between 23 hours 16 minutes to 24 hours 14 minutes. Measurement of day and year. So we will talk about the sidereal day. A sidereal day is the time it takes for the Earth to complete one rotation about its own axis with respect to the distance from a star. It is approx 23 hour 56 minute. Apparent solar day. A solar day is the time it takes for the Earth to complete one rotation about its own axis with respect to a distance from Sun. From Kepler's second law, the speed of Earth around the elliptical varies as the distance from Sun varies. Apparent solar day will not be constant value. Length vary from 23 hour 44 minute to 24 hour 14 minute. Maximum difference is 16 minute. Remember that one for Dgca exam. Mean solar day. The mean solar day is the average length of an apparent solar day. It is a constant length and related to light and darkness. It is used as a civil day and divided into hours, minute and second. It has exact 24 hours. Civil day. A civil day should be the period of time the calendar day of 24 hour duration calculate from one midnight to next. The civil day should therefore be based on the sun. Civil days should be constant length. Remember that. The maximum difference between mean time and apparent sun time is about 16 minutes and occur in mid-November. Remember that 16 minutes for Dgca exam. A second maximum occurs in mid-February at about 14-minute difference. A sidereal year is the time taken by Earth to complete an orbit of Sun measured against the distant star. Its length is 365 days and 6 hours. A tropical year is the length of one cycle of season. Its length is 365 days, 5 hours and 48.75 minutes. The Earth spins in a easterly direction, 360 in every 24 hours, from west to east. Twilight. Light seen before sunrise and after sunset. You can see twilight in the early morning and early evening. As you can see in the picture of one city, sun is about to disappear. That period are called twilight. If you see above from North Pole, the front part of Earth near sun is day and opposite part of Earth is night. And 1, 2, 3 section are called twilight, where sun rays are partially. Later on we will know the type of twilight for section 1, 2 and 3. So in this picture there is a morning twilight and evening twilight. Type of twilight. Civil twilight, sun 6 degree or less below sensible horizon. Duration is 21 minutes near equator. That is come under section 1. Nautical twilight, sun 6 degree to 12 degree below horizon or 48 minutes before sunrise. That is come under section 2. Astronomical twilight, sun is 12 degree to 18 degree below horizon, 72 minutes before sunrise. That come under section 3. So remember that one. The early morning is civil twilight, where the civil people wake up, and nautical twilight, where the shipmen wake up. Astronomical, where the astrological people wake up on that time. So remember 3 terms. Important point. In the plane of Earth orbit around the Sun is labeled the plane of eclipse. The plane of eclipse and plane of equator are inclined each other at the angle of 23.5 degree. Remember these terms. The angle that the sun is above or below the equator determine the season and affect the length of daylight and night. Sun cross equator twice in a year. With increase in latitude, the twilight period increase. Visual horizon is below the sensible horizon. Here you can see the visual horizon is just below the sensible horizon.